Okay, now we're still on the simple harmonic motion experiment, but now we're doing data table 3, the period of oscillation. We're going to use the period of oscillation to calculate the K value. The K in this case is going to be 2 pi squared, 2 pi quantity squared, so it'll be 4 pi squared divided by the slope. And the slope we're going to get is we're going to plot T squared, the period, divided by the mass that we supply. So first we need to get a period. How are we going to get a period? Well, we're going to let me minimize this so that we can see everything. Hopefully you can see all that. Everything, I left everything the same from doing the spring elongation. So it's the same displacement, the natural length, mass equilibrium, and the movable line. We're using Earth gravity, and we're gonna take no damping, no damping along at all. That'll make our calculations easy. And I'm going to go ahead and use this uh, 300 grams. This will be the slowest period that we have. So what we want to do is uh, we want to get this oscillating, uh, and using the oscillations. Let's see, we have a timer here. We can bring this timer, and I'm going to count whenever this reaches its max. I'm going to start it. When I start it, that's the 0 count. I won't count 1 until it goes back up to the top. I find it easiest when it's at the top, or if you want to do it at the bottom, that's fine. So that when it gets to the top, I'm going to start it, and I'm going to count to 10. So start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that was 10.84. Let me write that down. 10.84, so that's 10.84. That's 1.84 second, 1.84, a period of 1.84. That's for the 300. 1.84 seconds. Now, I'm going to do that again. Let's reset it. And I'm going to do that again when it hits the top. Start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10.89. So that's 1. 1 point, 1, 1 point, I wrote that down, 1.89. The last one should have been 1.084. I wrote down 1.84. Let me correct that. Make that a 0, 1.084. And let's do it one more time. And what you're going to do is you're going to average these values. Okay, start it at the top. Start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it's 10.85. Now you take those, so that'll be 1.085, a period of 1.085. You take that, average those three values, and that's your period for the 300 grams, 300 gram mass. Now let's I don't know what you're going to use. That may be too uh, fast to count. What did we have anyway? We had like 53. That's still going to be pretty fast. 56. So let's put this uh, at 56. Let's see. This might be a comedy of errors. Let me. Uh, okay, and let's see if we can count this. Um, when that arrow is all the way at the top, start. One, no, that's too fast. That's probably too fast. Uh, let's stop it. And let's start 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it's 4.8. Now this one you probably should do 3 times and get an average because it's gonna, so that's 0.48 seconds per period. Let's try it again. Let's reset it. And when it gets to the top, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 4.75, 0. So that's 0.475. And let's try it one more time. And it get to the top. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, 0.475 for the period. The 4.75 seconds divided by 10 gives you 0.475. So that's your period. You do that for the different masses that we did in the, they're only asking for 5. So it might be best to use the last 5 that you had in your table, data table 2. And you come up with the periods, you plot it on data table 2. I mean, you put the data in data table 2, square the periods, and you plot it, period versus mass. And you're going to get a slope, and the K is equal to the 4 pi squared. That's 2 pi quantity squared, so it ends up being 4 pi squared divided by the slope, and that's your K. Okay, I think that's a good enough explanation for doing the part C, period of oscillation. All right.